working with perfect squares and perfect cubes. Now, anybody know just from being around on this planet what you know? What's a perfect square? So just put up your hand and let me know. What do you think a perfect square is? Try it out.
Where both sides or all sides are equal.
Yes, it's true. It is a square like this. All sides are equal. Okay, again, totally different definition than I got from the first class. Both equally is correct, right? Who's got another way to say perfect square? Yes. Ah. Yeah, that's actually what in the last class people said they got to be whole numbers. But in this square, can I have a side 0.3? Yeah. So 0.3 times 0.3, this would be a square of 0.09. So perfect square, if you take the square root of 0.09, it is 0.3. Okay? So that's excellent. All of my grade 10s think that when they come. They're like, got to be a nice, as long as it is a terminating decimal, it's a perfect square. Okay, 0.25 times 0.25. Okay, yes. So you're thinking that's redundant. Yes. In this example, I would agree with you. But a perfect square, as you will learn, it's when any number can be square rooted, and it works out to be a non-terminating decimal. Okay? So this example, I agree with you. Like that's like saying a round circle. Yeah, I mean that's like, or a dead corpse. Pretty sure it's dead, right? Right? So this is redundant according to this picture. Okay. Now, so a square root is kind of like the opposite of, because 0.3 squared is 0.09, and as you see, the square root of 0.09 is 0.3. Because it's the very basic, the simplified. Yeah, get to the root of the problem. Let's just get right down to the basics. Okay? Because the square root of 49 is 7. Okay? Now, the number 81 is a perfect square since it has a rational number as the answer, as the solution. Okay? So, no irrational numbers, and you're fine. C squared 36? 6. Square root 49? Square root of 132? Okay, so let me write this down. So we have this example. It's 11.48912529 ... Now this is not perfect, exactly. So this is not perfect. So to us, perfect is going to be terminating. Yes? Yes. Because non-terminating with repeating is rational. Right? And that's why we went through those number systems last class, because I needed you to have that foundation. But irrational, dot, 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 and no pattern. Okay? You need those two things. Now, what we're going to do is we're going to do all of these without our calculator. Okay? And so I don't want any calculators out. Okay? Let's do these with our brains. No, let's just do them together. Square root 16.
4.
81.
9.
169. 225. Good. 2,500.
76. 9. Wow.
Yeah. Okay, square root of 19.
0.4.
Okay. So we got 4.2, we got 4.4. Any other guesses? 4.3. Okay. So can anyone give me a way to be able to estimate these? Okay, just let's work with this. What's a way to do these? Okay, give me below 19.
16.
So that equals the square root above. And that is. Okay, so I just want you to look at this, please. So if you have 5 and 4, you have to decide 19, it's maybe a little bit closer to 16, right? Like if this was square root 24, I'd be going closer to 5. But because it's square root 19, I'm going to be going closer to square root 16. And so the answer is 4.4, actually. Okay? Now, 44. Okay, what's the one above? 49, the one below? Okay, so we're looking between 6 and 7. $6.8? 6.6.
Oh, come on.
Now, if you put 6.7, depending on what kind of mood I'm in, I might mark it right. Might. No promises. Square root of 36. 0.09. Okay. Now remember, when you're multiplying a decimal by a decimal, the number gets smaller. Okay? I don't know if you remember. Do you remember the time when you multiplied two numbers and it was a bigger number? And when you divided a number by a number, it was smaller? Remember when things were simple? The grass was greener. The birds were chirping. You were content. Right? You go outside in the playground, 6 times 5 is 30. It made sense. But then along came 6 times 0.5, and what do you get? 3. So now you're multiplying and getting smaller numbers? Like, what's up with that? Well, at least division is safe. Because I know division, when you divide, it's always smaller. So 6 divided by 0.5? 12. What? So now you're dividing and then getting bigger numbers? And that's where, for some people, they just fall apart. You see them crying in the playground. I liked it better. Yeah. Square root 0. Square root negative 25. Can't do. Okay. Can anyone please... Okay, Matt, if you have a question, just put up your hand. Can anybody explain to me why you can't do this? Yes? Exactly. So you needed to, if you said it was negative 5, and you tried it, that gives you 25. So, be careful. You can never take the square root of a negative number. Okay? Now, square root of 65. Give me a nice perfect square above it. Oh, that's going to be 81. Okay, so we can see how much closer we are to 64. So we are between 8 and 9, but I would go closer to 8. 8.1. Now, one thing while I'm here, because I remember this with, oops, sorry, let's go back. I want to we need to make this note. Now, can everybody just put this into their calculator for me? I just want you to put negative 5 squared and then equals. And what do you get? Okay. And you know what? This has to begin to make sense for you using that tool. That is the calculator you'll have for the next 3 years and one you're going to take into your diploma. You have to understand that it will give you the calculations for what you put in. It's not a mind reader. It doesn't know what you mean. Okay? It just knows what you're saying. So when you're saying negative 5 squared, what is squared? Just the 5. So how do you tell your calculator, I want negative 5 squared? How would you do it? Right. So you have to put it in correctly. Like if you want to know what's negative 5 squared, you need to put your brackets. Yes. Okay, I can't hear because people are talking. So we have to stop with the comments and stuff right now? Yes. Okay, that's another excellent question that I need everybody to watch here really closely. If it said x equals the square root of 25, the answer to that is only 5. Okay? Now, that's just something that is kind of ingrained in the mathematics. The square root of 25 is only 5. But what if you had this question? X squared equals 25. That's the way the question was set up. Now, I'm thinking this way. And okay, that way there is 2 answers. Now, but here's how I'm just going to show you how even more similar they can become. When you see x squared equals 25, how do you solve it? You take the square root of both sides. Now, if you take the square root, do you see in this example here, are you taking the square root? No, that's the way the question was set up. You are algebraically doing that step. Whenever you algebraically do a square root, you must put a plus or minus in front, and then you will get x equals plus or minus 5. Okay? So look how similar those are. They both have square root 25s, but one you did as an algebraic step. The first example I gave you, it was given to you that way in the question. If it's given to you that way in the question, it will only be the positive answer. Okay? Only if it says x squared equals. If it says x equals the square root of 25, what's the answer? It's only 5. It's not negative 5. Okay? And that's something that the grade 11s and 12s, they learn. So hopefully that'll be reviewed when you get there. Okay. Now, here's one of the hugest errors. This question right here. It says a square has an area of 169. Determine the perimeter of the square. So, if you were to draw this square, put 169 in it, what would be the dimensions of it? This would be a 13 by 13 square. So, the perimeter would be 4 times 13, which is 52. What's the most common? What's the most common wrong answer do you think I get? 26, actually. They add the two sides. And they go, it's a 13 by 13, so they add them together and they say that's the perimeter. Because they get 13 by 13 as their answer, and they add them together. Okay, we're going to skip that part, and we're going to go on to perfect cubes. Now, perfect cubes, and you're going to learn to the 5th root to the 4th, they have a very unique difference to the perfect squares, and this is the difference right here. What is the cube root of -8? -2. Why? Because -2 times -2 times -2 equals -8. If you have, okay, you guys don't answer out, okay? I need to. Now, so you can take cube root of negatives. The cube root of 8 is? So there isn't going to be that. If it's negative, it would have been if it's a negative solution, there would be a negative square root. Okay, if it's positive, it will be a positive square root. Okay, so that's one thing that you will notice. And a perfect cube is going to go with basically the same principle. 27 is a perfect cube because it is 3 times 3 times 3. So we're looking for 3 identical numbers that multiply to get me that number. Now, and we'll talk about this more when we get to the other page, but so the cube root, don't mix that up with the cube of, okay? Or 8 cubed, I should say. 8 cubed means put a 3 on top of it. The cube root of 8 means, and that's where you get your 2. What's the cube root of 64? And the cube root of 125 is 5. Okay. Now, how do you take and find out if some of these numbers have perfect cubes or perfect squares or whatever? Well, there is a way that's called prime factorization. Okay, you guys, please. That's bugging the people that are trying to. Now, the first thing you do is you put the number 729 and just put a little kind of backwards L. Now, the thing we have to do is we've got to find a number that divides into this. Now, in junior high, you should have been exposed to some insight on how to just look at a number and know, hey, that's divisible by this. Okay? Now, if you don't, just put up your hand, don't yell it out. But how can you look at a number with the most minimum evidence? I know I need the most minimum evidence that it's divisible by 2. So how do you look at a number and go, I know that's divisible by 2? Yes. Okay, be specific. Because 83, 8 is even, but that's not divisible. Last digit. Okay, so that's the most minimum evidence you need. I don't care about all the rest. If the last digit is 0, 2, 4, 6, or 8, that number is divisible by 2. Okay? I'm putting up your hand. 3. What is the way that I can look at a number and instantly go, that's divisible by 3? How can I do that? Yes? If you add up all the digits, like I want to give you an example. 72. We know that's divisible by 9, right? But if you add 7 plus 2, that equals 9. And 9 is divisible by 9. Okay? What about this one that we're doing right here? 729. 7 plus 2 is 9, plus 9 is 18. Is 18 divisible by 9? Or 3, I should say. Okay? So if all the digits, if you add them up, if their sum is divisible by 3, the whole number is divisible by 3. Okay? 4. Okay, so 4, the most minimum evidence you need is you need to look at the last two numbers. Like 24 is divisible by 4, correct? 724 is 2. Because the last two, if the last two numbers are divisible by 4, 8,700,000 and 24 is divisible by 4. If the last two digits, or last two numbers, are divisible by 4, so if the last two numbers are 16, 28, 32, doesn't matter what the rest are. And 8 has a very similar rule, but it's the last three digits. So 8's not as nice, because not too many people can look at a three-digit number and go and know if it's divisible by 8. Okay? 6. 6 is a clever one. No one? 6 is, if it's divisible by 2 and 3, it is divisible by 6. And it's easy to remember, right? Because 2 times 3 is 6. So if it passed the 2 rule and the 3 rule, the 6 rule guaranteed will work. Okay? Like, I'll just use an easy number, 12. It passes the 2 rule because the last digit is even. It passes the 3 rule because 1 plus 2 is 3. 3 divided by 3. Therefore, I guarantee 6 works. You've seen these before, right? Some of you have. Okay? 9 or 7. 7, you're out of luck. There's nothing. 8, last three digits. 9. What about 5? Missed it. 5 or 0. 10 ends in 0. 9 if the two digits are divisible by 9 if you add them up. Or all the digits. Okay? So 72 works, right? But I know that also 972 would work. Right? And if I wanted to, I could add like this, because that's 9 plus 9 plus 9, right? 27. So you could make numbers quite easy and be quite confident they're divisible, because if you add up the digits. So if we were doing prime factorization of 729, you would be surprised 1, 2, and 5 get you out of 99% of your jams. Okay? Odd times 7. But 8 is divisible by 2 or 4 anyway, so don't go for 8, right? So 1, 2, and 5. Because you don't even have to do 4, you already did 2. So, well, 1 is a waste of time. So 2, 3, and 5. So the number we should try for this one is what? 3. Okay, and then you can put that into your calculator. Now, I know what you're thinking. You're like, I could have used my calculator the entire time. If you don't even know to look for it, you would probably say, oh, that can't go. Okay? So when you take that, you will get 243. Now, 2 is out. How about 3? Yes. And you get 81. Now don't go for 9 right away. Keep getting the prime factorization, because 9 is not a prime. We want all prime numbers. What about 3 again, and I will get 27. Do 3 again, I will get 9. Do 3 again, I will get 3. And then you should do 3 again until you get the 1 at the bottom. You know you're done when you get the 1. Or you get a number that cannot be divided anymore. Now, these are your no, don't add them. If you multiply those together, you'll get 729. So why? I wasted my time. What can I do with that thing? What's another way to write 729 then? Right, 3 to the power of 6. Now, I'm really going to mess with your heads here, because there's other ones. Now that's the prime one, but what's another way we could do it? See, we've done 3 times 3 times 3 times 3 times 3 times 3. But we can also do this. Since there are, this is the same thing as 9 times 9 times 9, right? Which would be 9 to the power of 3, which also works. Okay, now there's another one. You just line them up. You can also go that would be 27 times 27, right? Which is 27 squared. Now only one is the prime one. That's 3 to the 6. But the other are correct answers. So you can see by just doing your grouping. Okay? And we're just going to skip the 3 methods right now, and we're just going to go some examples of prime factors. What's the first prime number? No. 1 is neither prime nor composite. 2, 3, 5, 7, 11. It's after 11. 15 is divisible by 5. 13, 17, 19. So what is the, from my example, what is the definition of a prime number? Yes. So prime numbers only divisible by 1 and itself. So that is why 15 fails, because it's just not 1 and 15, it's 3 and 5 as well. If there's any other factor out there, it's not prime. Does anybody know what the largest prime number in the world is? No. Because they keep seeing if they can find it, right? But I think that at this point, they have published what the biggest prime number they found to date is. Okay? Because it's not like they can't keep trying and trying and trying, right? And there's no mathematical program that they can write for it. Okay? And now, example of a number that is not prime would be anything like 8, 25, you know, I think you get it. And for some people, this is extreme review. For some people, it's new. Okay, now just by looking at this diagram, what would you... It's awesome. What would you say the dimensions of this cube? So 5 by 5 by 5, okay? Okay, now we're just going to go down to the bottom here. Now, just so we have this, how do you get cube 216 into your calculator? What's the first button? Okay, so write this down. We hit math, 4, and then you put your 2, 1, 6, and then you hit enter. Okay, so just getting into the math mode, using your calculator more and more. So you obviously, grade 10 is just a year of really learning how to even just turn it on to finding all the tables and everything like that. Now, what I want to actually use your calculator for is what a really good tool for this is, okay? because we're going to be doing these without a calculator, but I want you to kind of draw a chart here of x, x squared, and x cubed. Okay, so you have room on the side there. Yeah, we're just going to, because you need to know this. You need to memorize. Now, memorize here is different than what you really know as memorization. I don't want you 243. What is that one? I want you to be able to see the number 243 and go, that has a perfect cube. I know that one does. And then do perfect cube in your calculator. Okay? Now if you know it, that's awesome. But when you see 243 and a little bell's not going off, that's not good. Okay? So let's just go, when we have our 1s, they share that. 2s would be squared, 4 and 8. 3 squared is 3 cubed is 27. 4 is 16 and 4 cubed 64. 5. Now I expect you obviously to know your perfect squares. 25 and 125. 6 is 36 and 216. 7, 49, and again 343. Whenever you see that number 343, I want you to think I should try cube rooting that. I should try square rooting it. I should try cube rooting it. I know it's on that table. Okay. 8, 64, and 512. 9 is 81 and 729. 10 is 100 and 1,000. Okay, 11 you should know is 121, and this is 1331. So that has a very unique, okay, when you're squaring it has a 121, when you're cubing it has a 1331. I will, I'll show you that. But I want you to write these down right now, because I've been, okay? Because the chart won't help you in some situations. You can ask my grade 11s, because some of them are not able to just 343. I should be looking, they're leaving it under the square root sign. And when we start doing radicals next year and you have to take everything out that can be, they're leaving stuff in because they're not recognizing it as, that can be pulled out. Now, I showed you this on your calculator, right? How to do the table. Yeah? Okay, so I have to just go to, okay, it's good. So when you go to your y equals, I don't know why it's always defaulting to this, but you just want to go x cubed. And then you go second graph. And that'll give you the chart that we just wrote down. And if you really want, you could go like this. So if I go to y equals, and I put this as x squared in my first one, and x cubed in my second one, and then I hit graph. Okay, this will be your two graphs. When you hit your table, it has it all there for you. Now you can see that when you square any of your x's, they become positive, and when you cube them, they still remain negative. How did I get here? So you get this part? Hit the Y. See where my arrow is? So x exponent 2. Here's your exponent button right over the division sign. Right there. And then put your 2. And then in y2, put x. And x is always this button. X with a square root of 3.
What if you put the alpha?
Yeah, that does matter. Yeah. No. Okay. Now, here's another thing too for anybody that wants to. What's wrong? You have to hit second graph though if you want the table. So if you do this, so not so I'm going to get rid of my second graph. I want to show you the actual graph. But if you hit the trace button, you can just watch. But if I hit trace 2 enter, it'll show me that it's 2, 4. And 8 would be, you can't even see it because 64 is way up there. Okay? 3. So it'll actually give you the exact point and where it is. Okay? And that's the, what we call a quadratic. That's the parabola. And you can see how it increases. And then if I want to change my window settings and I want my x max, that's weird that it did that. I could actually make that 0, my x min, sorry, and say this like 200. Okay, that's the graph under that situation. And then now I have, and all I hit it is trace, and then I could go 5, enter. It's going to give me 25. 6, enter. But what's even nice is I could be doing 1.2, enter. It would be 1.44, okay? 0.8 should be 0.64, okay? So this is your introduction to looking how does the picture relate to, that's what graphs are. They're the picture of all the information. And, you know, they say that a picture's worth 1,000 words, but a graph is the only way to actually explain all of the points. Because just the points between 1 and 2, there's 10 gazillion, let alone the entire graph. Okay, and you'll have lots of time to play around with that. Now, let's do just some other ones. What's the 4th root of 16? Is there 4 numbers that multiply together that give 16? 2. So the 4th root of 16 is 2. How about the 5th root of negative 32? Yeah, I skipped the 1 step. Negative 2. 4th root of 81. So we're looking for, is there 4 numbers that multiply together? Why 4? Because the 4th root, and they all have to be identical. 3, yeah. Because if you put 3 times 3 times 3 times 3, it gives you 81. So the answer is just 3. Those are some other roots. Same way you did. You put a 4, then math, pick 5 this time, and then put your 16 inside. Now, if you come up to here, because I wanted just to do that backwards, 125, perfect cube, perfect square, which one? Okay, what times 1 equals 125? No, 5 times 5 is 25. Is there 2 numbers that multiply to give me 1? So this is perfect cube. How about 64? Okay, so the square root of 64 is, the cube root of 64 is, so this is both. Could be a perfect cube or a perfect square. How about 216? Just the cube. 729. Okay, if it's both, what's the square root of 729? Nope. 27. And the cube root of 729, you should all know that, is 9. Okay, so that's all the examples we're going to do on that. Now we're going to get to the last thing here. Now, what I'm about to show you, I think has been taken out of the junior high curriculum, but I used to teach this to my grade 7s. And it was a trick that I had learned from another math teacher, and it helped my students so much on finding lowest common multiples and greatest common factors. Do you remember those? So let's work with GCFs. This is greatest common factor. Could someone put that into English for me? Okay, just putting up your hand. What does GCF even mean? What does it mean? Okay, and just put up your hand, okay? Don't yell it out. Okay, try it. What do you mean shared? Because 4 and 8 applies to both of them. Okay, so you're missing a piece of information that I need that's really different than LCM. Because LCM, it's a number that applies to both of them. What are factors? Numbers that go into it. What are multiples? Numbers that they can go into. Okay, they're very different. So GCF, let's do an example here. Let's do the GCF between 84, 294, and 282. So the way you do this is you just draw a line like that. Now I need a number, and give me the prime, a prime number that goes into all three of them. 2. So if we put a 2 there, then we're going to divide. 84 divided by 2 is 42. 294 is 147. 282, oh sorry. This is supposed to be 882. So 441. Okay, then you go like this. Now, is there a number that goes into these? 3? Okay, what's 42? Fill that line in for me. Oh, I missed it. Okay, what would be my next line? Okay, what are they? I need the numbers. Okay. Can I keep going? With what? Okay. So that will give me 2, 7, and okay. Is there anything that I can do now? Okay. So if you can't go anymore, you stop. Now the GCF what is the biggest number that goes into all of them? All you do is you take these numbers and you multiply them together. So 2 times 3 times 7, which is 42. That is the greatest common factor of those three numbers. So you just always use this chart, and in GCF, you must go into all numbers. Now the reason I tell you that is because LCM. Now LCM is the lowest common multiple. We used to need those, and we're still going to need those when you are finding out what is the lowest common multiple. What's the lowest number that I can use that all those go into? Because if I need to add or subtract fractions, I need to know that. Okay? So the numbers we're going to use are 15, 36, and 48. Now this is pretty challenging for most students. If you ask them, find me a number they all go into. The lowest one. Now if you want to find the biggest one, multiply them together. Okay, well, it's not the biggest one. You can go bigger than that. But that's going to be a common multiple. If you multiply those three numbers together, I'm pretty sure there'll be a common multiple because we multiplied them to get it. Now, here's the trick on how to find the lowest common multiple. Okay? There's some really complicated charts and weird things. Even in these notes, I'm looking, I'm going, oh, that would be so confusing. But the GCF chart, if you get it, we're going to do the same thing. There's only a couple little differences when we get the answer. Now, what is a number that goes into all three of them? 3. So that will give me 5. That will give me 18. Oh no, I'm doing 3, not 2. That will give me 12. And this will give me 16. Okay? Now give me a number that will go into all three of them. No. So here's the difference between GCF and LCM. Must go into, sorry, my writing's bad here, at least 2. So you don't have to go into all of them. So what is a number that goes into 2 of them at least? 4. Right? Because it's 12 and 16. But what am I going to do with the 5? All you do is you bring the 5 down. And 12 divided by 4 is 3. 16 divided by 4 is 4. Now, can you go any more? No. So then, all you do is you draw your L. Since it is the LCM, draw the L. So that's the one big, there's 2 differences. GCF, just multiply the side. LCM, multiply the L, and you don't have to go into all of them. And then you get 3 times 4 times 5, so you go 3 times 4 times 5 times 3 times 4, and you get the answer 720. So 720 is the smallest number that they all go into. Okay? So those 2 charts will get you through every GCF and LCM question. Yes? Which part? The lowest common multiple, if I was to add, if you just watch this here, if I was to add 1/2 plus 1/4 plus 1/3, I just can't go 1 plus 1 plus 1 equals 1, and 2 plus 6, 9. You can't do that. So you have to get all of those common before you can add them. The lowest common multiple is the smallest number that all 3 of those go into. And that number would be 12. So you have to convert this. What do you have to do here? You have to multiply by 6. So I'm going to do that. That's 6/12. See, it's still 1/2. But I made it 6/12. This, I got to multiply by 3. I'll do the same thing here. this I got to multiply by 4. I'll do the same thing here. What I have done is not change the question at all, but I've made it so I can add 6 plus 3 is 9, 9 plus 4, that's 13 over 12. So before you can do these, you need to know how to do this. And if I was adding 2/15 plus 7/36 plus 8/48, I got to find a lowest common multiple before I went and did that. So this is also called LCD, lowest common denominator, or lowest common multiple. They're the same things. This one, or this one, 720. 720 would have to be my common denominator before I started the question. I multiplied my L together. Yes?
So can you use these charts?
Yes. Okay. So here's what we're working on. Right there. Matt, use it. Don't pack up whatever you do. Because whatever you pack up before the bell, you can do after the bell then.